Assalamualaikum and welcome back to my video presentation on problem-based learning. The 3C3R model is a comprehensive guiding principle for PBL practitioners to design an authentic PBL problem based on the real-world scenario and meet the intended learning outcomes of a study course or a program. However, it is not sufficient to just understand this model without being able to practically use it to design our own authentic PBL problem. In this presentation, I will be sharing a step-by-step problem design process using 3C3R problem design model based on my own experience and some other observations on issues forwarded by academics and teachers during our training sessions. This could be a good start for us, PBL practitioners and educators, to find the best way of designing authentic PBL problems to meet the intended learning outcomes of our specific study course or program. As discussed in the previous video, the 3C3R PBL problem design model developed by Professor Wei Hong specifically to guide PBL practitioners to design effective PBL problems for all levels of learners and strengthening the characteristics of PBL and alleviating implementation issues related to the lack of content mastery and learning skills. The model proposes two main components, the core components and the processing components. The core components support the learning of content and concept and consists of content, context, and connection, whereas the processing components support the learning process and consists of researching, reasoning, and reflecting. And having understood this model, PBL practitioners should be able to find the best way to apply it in their problem design process. Our previous discussion on PBL educational models indicates that there are three main phases of PBL. One is problem design, two is learning cycle, and three, assessment and evaluation. The guiding principles as discussed by Howard Barrows and Linda Wee in our previous discussion had pointed towards the importance of authentic real-world problems in designing a PBL problem. 3C3R models, on the other hand, pointed towards a more practical way to design a PBL problem to meet the intended learning outcomes. There are at least 10 essential steps involved in designing an authentic PBL problem. Step 1 is finding the real-world problem. Step 2, identify the main content of the problem. Step 3, identify the learning process and context from the problem. Step 4, identify the possible connection of the problem to the student's level of prior knowledge and skills. Brainstorming activities in steps 2, 3, and 4 should be able to classify the core components of the problem, including the content, the context, and the connection. The common practice in designing learning outcomes could be a good point of reference to measure the level of content, context, and connection. Take, for instance, a civil engineering course. It might consist of 75% of core content and 25% of general supporting content. In 75% of core content, there could be 50% of core civil engineering content. Another 25% could consist the core supporting content such as other integrated engineering subjects, applied mathematics, and also science. The 25% of general supporting content could consist of arts, technology, social science, and essential skills. Step 5. To select the most appropriate format of the authentic problem scenario and complete the design. According to Barrows and Linda, as we discussed previously, there are at least 7 common formats of the PBL problems. One is written or printed problems. 2 is the PBL module. 3 is a computer simulation. 4, virtual and augmented reality. And 5, human simulation. 6, models. And 7, actual problems. We have briefly discussed these 7 formats in our previous discussion. Step 6. To align the problem scenario with the course of program learning outcomes. The practice of constructive alignment would certainly be very helpful for a problem designer to use and achieve this goal. The common framework of constructive alignment is first, one is to identify the intended learning outcomes, to design assessment tasks to measure the attainment of the learning outcomes, and 3, to plan the learning activities for students to achieve in the intended learning outcomes. Step 7, to decide on the format of the learning cycle model to incorporate the processing component, researching, reasoning, and reflecting. In our previous discussion, we came across 3 different PBL model practiced at Temasek Polytechnic and Republic Polytechnic of Singapore and University Tun Hussain Othman, Malaysia. As we understood that PBL is not one size fits all, PBL practitioner is free to design their own model that suit their needs, the students' background, as well as the institutional curriculum requirement. Step 8, to pilot the problem scenario using a specific inquiry approach such as FILA or FACTILA or any other approaches deemed appropriate for the specific discipline area and the problem format. Problem designers should put themselves into the shoes of their students and think like them. Then start working on the inquiry process on the problem scenario, and the final result of this inquiry process could be used to set the assessment standard for the students' inquiry process and the actual learning process. Step 9, to review and evaluate the problem scenario using a specific reviewing procedure, such as using a reviewing form developed purposely to identify the appropriateness and quality of the problem scenario. Linda Wee, 2004, provides a general guideline to review and evaluate the problem scenario by asking these 15 essential questions. 1, does the problem relate to real-world demands? 2, is the format of the problem similar to the real world? 3, is the problem open-ended and not limited to one single correct answer? 4, does the problem require students to engage their prior knowledge? 5, does the problem require students to make judgment based on facts, information, and reasoning? 6, does the problem require students to seek, evaluate, synthesize, and apply new information? 7, are there adequate and accessible resources to support students' self-directed learning? 8, does the problem require students to formulate an action plan to obtain a solution? 9, does the problem require students to function as a group by tapping individual members' diversity, knowledge, and ideas instead of delegating and subcontracting tasks among themselves? 10, does working on the problem require students to exhibit the types and sequence of behaviors needed in the workplace? 11, is the problem considered to be high impact by the industry? 12, does the problem have a high frequency of occurrence in the industry? 13, is the time allotted for managing the problem sufficient? 14, does the complexity of the problem correspond to the phase of the curriculum? And finally, 15, does solving the problem satisfy the attainment of exit outcomes of the curriculum? Reviewers should be selected from fellow educators, especially those from similar or related discipline areas. And to facilitate further and speed up this reviewing process, the problem designers should prepare the evaluation form and decide on the level of acceptance using scores or percentage. Step 10, to plan for its implementation, including taking into consideration of the cost or program coverage, the personnel involved, the duration, students' learning progressions, the assessment procedures and process, as well as scheduling for the next problem review process. These 10 steps of designing an authentic PBL problem is cyclical in nature. The problem scenario that goes through these 10 designing steps and then successfully presented to the students to complete their learning process should be improved through continuous assessment and evaluation. And the process will continue as long as the problem is within the cycle of the curriculum. I may not be able to share a specific example of the problem scenario in this short video presentation, but it was my great intention to do so in the upcoming video presentation. For now, I hope PBL practitioners and educators who watch and learn from this presentation could apply these 10 steps of designing an authentic problem and share their experience with others. Thank you very much for your time and kind attention to my presentation. Viewers who are new here, please subscribe to my channel so you'll get more notification on my upcoming videos. And don't forget to like and share this video. And if you have something to share, please leave the comment below. Have a great day. Assalamualaikum warahmatullahi wabarakatuh.